Hello everyone, and welcome to the second part of our exploration into relations and functions. If you've just joined us or missed the first part, we encourage you to watch that video for a comprehensive understanding. In today's session, we delve deeper into relations within a set. Let's continue our journey of understanding with our first topic, relations on a set A.
Consider a non-empty set A. Then in this context, a subset of a cross A is also a relation from A to itself and is known as a relation on set A. For a clear illustration, let's take the set A 1 to 3, 4. In this case, the relation R equals 1, 3 for 1 and 3, 4 is an example of a relation on set A because R is a subset of a cross A. Now let's discuss various types of relations on set A. Beginning with the universal relation.
Universal relation. Consider A set A, then a relation R equals a cross A, which is an improper subset of a cross A, that is, a cross A is a subset of a cross A, and so, a cross A is a relation on A and is known as the universal relation on A. Universal relation can also be known as a full relation, as every element of set A is related to every element of A.
Second, void relation. Let it be a set. Then, phi is a subset of a cross A is a relation on A, which is known as the empty relation or void relation or null relation on A. For example, let A equals 1, 2, 3, 4, then the relation R on a set A defined by sum is greater than 9 is a null relation because there doesn't exist any ordered pair, say x, y belongs to R such that x plus y is greater than 9, that is R equals phi. Third, lentity relation. Consider a non-empty set A. Then, the relation A, such that A belongs to A is known as the identity relation on A and is denoted by I with subscript A. In other words, a relation on a set A is called the identity relation if every element of set A is related to itself only.
One may note that a relation on a set A becomes the identity relation if, and only if, each element in A is related only to itself, and no element in A is related to any other distinct element in A.
For example, let A equals 1, 2, 3, 4. Then the identity relation, that is I equals 1, 1, 2, 2, 3, 3, and 4, while as relations like 1, 1, 2, 2, 3, 3, and 1, 1, 2, 2, 3, 3, 4, and 1, 2 are not identity relation on it, as 4, is not including in the first relation. That is, all ordered pairs like A for all A belongs A are not included, and 1, 2 is including in the second relation. That is, an element in A is related to any other distinct element in A.
Fourth, reflexive relation. A relation R on a set A is said to be reflexive if every element of A is related to itself. Thus, A is reflexive if and only if A belongs R for all A belongs A. Example, let A equals 1, 3, 5, then R equals 1, 1, 3, 3, 5, 5, and 1, 3 is a reflexive relation, but the relation R dash equals 1, 1, 3, 3, 5, 1, and 1, 3 is not reflexive as 5 belongs A and 5, 5 doesn't belongs R dash.
Thus, considering the set A equals A, B, C, D, if any one of the ordered pairs A, B, B, C, C, and D, D is absent in the relation R, then the relation cannot be reflexive. Second example, let L equals set of all lines in a plane. Then, the relation on L defined by L1, L2 belongs R double implies L1 parallel L2 is reflexive as Li parallel Li for all I, as every line is parallel to itself because the perpendicular distance between them remains same and is equal to 0. Note, by the term line we conventionally mean straight line.
3. The key distinction between the identity relation and a reflexive relation is that the identity relation contains solely identity elements, pairs where each element is related to itself. On the other hand, reflexive relation may include elements beyond those of the identity relation. Fourth, 1 R equals x, y such that x, y belongs to natural numbers, and x is greater or equal y is reflexive on n, because every natural number is equal to itself, which implies A belongs to R for all A belongs to n. Note, The universal relation on a non-empty set say A is reflexive as it contains all ordered pairs like a comma A belongs to a cross A for all A belongs to A. The identity relation on a non-empty set say A is always reflexive as it contains all ordered pairs like a comma A belongs to identity relation for all A belongs to A. 2. The identity relation on a set A is a specific type of reflexive relation where only the identity elements pairs like a comma A are present for all A belongs to A. 3. Reflexive relation on a non-empty set A is not necessarily an identity relation because a reflexive relation may contain elements like a comma B such that A is not equal to B for some a comma B belongs to A other than identity elements. 4th, if R is a relation on empty set phi, then there are no elements to check for reflexivity, so the relation R on an empty set phi is vacuously reflexive. This is because there are no elements in phi for which the condition of reflexivity needs to be satisfied.
In the third part, we will discuss more types of relations like irreflexive, symmetric, asymmetric, antisymmetric, transitive, and equivalence relations.
Thanks for watching, and don't forget to like, share, comment, and subscribe. Stay tuned.